Hello, this is a short explanation about Hooke's law, about how to solve questions about Hooke's law. When we apply a force to a spring, it experiences a deformation. It gets longer. This deformation is proportional to the force we apply. The higher the force, the bigger the deformations. For instance, let's see. This is a hook. This is spring. Okay, and we're going to exert a force. We call force 1. The length of this spring we can call it x1, and the length of the second spring we can call it x2. The higher the force, the longest the spring. That's quite straightforward. So we can write the formula like this: F equals K times X. F is the force that we exert, K is the spring constant, and X is the length. The force is measured in Newton, the length is measured in meters, and the spring constant is measured in newtons per meter. And this is a characteristic of every spring. So it depends on the material of the spring, if it is big or small, things like that. But the unit is always Newton per meter. We have to work in the international system of units, as we know. Okay, so let's solve example number 1. A spring has a spring constant of 100 newtons per meter. Calculate the force needed to stretch the spring 3 centimeters. Okay, so as long as we are talking about springs, we know that we have to apply Hooke's law. First of all, we have to write the formula. F equals K times X. And what do we have here? We have the spring constant. Okay, so K is 100 Newton per meter. We have the stretch of the spring, X is 0.03 meters. Okay, 3 centimeters. We cannot use centimeters because, the spring constant is measured in meters, newtons per meter. We cannot mix units. Remember that. It's very important to use international system units. Do we have the force? No. We have to calculate the force. So, what are we going to do? Force equals K, which is 100, times X, which is 0.03. F equals 3 Newton. Okay? So this is the easiest problem. They give you the spring constant, they give you the length, and they ask you to calculate the force. The only thing is to use international system units. If you have the length in centimeters, which is very common, is usually is measured in centimeters, you have to change into meters. Okay, so let's see another example. Okay, so let's solve another example. The spring stretches 5 centimeters when we pull it with a force of 1.5 Newton. Calculate the spring constant and the length of the spring when we pull it with a force of 5 Newton. So here they are asking us for two things. One thing is first calculate the spring constant, and then we have to calculate the length of the spring when we pull it with a force of so and so, 5. Okay. We have a spring. We are pulling it with a force of 1.5 Newton, and we are producing a stretching of 5 centimeters. Again, we are going to write the formula here, and we are going to see what do we have. Do we have the force? Yes, we have the force. So 1.5 equals, do we have K? No, that's what we are asking to calculate. So K, we don't have it, but we have X. X is 5 centimeters, which is 0.05 meters. We need to use meters. We cannot use centimeters because the spring, the force is measured in Newton, and this should be, the unit is Newton divided by meters. Okay, so let's solve this equation. Okay, I'm going to use blue for this. K is 1.5 divided by 0.05. You can do this with your calculator, and you will find out that the result is 30 Newton per meter. Okay. Okay. So this is the first question. We have to use this data for the next question. The next question is the length of the spring when we pull it with a force of 5 Newton. That's what we are going to find out now. In this case, we know the force. The force is 5 Newton. We know K because we just calculated 30 Newton per meter. And we don't know X. So 5, we apply the same formula. 5 equals 30 times X. Be careful with this because you tend to do 30 divided by 5, and that's not right. X is 5 divided by 30. So X is 0.16 meters, and that's the result. If you want to give the result in centimeters, it's okay, but it's not necessary. If I ask you for a particular, in the exam or whatever, if I ask you for a particular unit, okay, you have to convert it, but if not, use always international system. If you want more information, more solved questions about Hooke's law, you can go to the planet Hooke. You remember the star quest? You have a lot of information on the surface of that planet. You have to look for it. There are like 4 or 5 craters full of information about Hooke's law. But I think with this, you will be able to solve all kind of questions about Hooke's law.